So, in case of like hybrid network or heterogeneous Wi-Fi network, let's demonstrate one of the small like scenario. Here, if we are taking one indoor scenario, which is having the four Wi-Fi installed on the ceiling, and many users are placed on the floors. Some of the users are just below the Wi-Fi access points. They can utilize the Wi-Fi. Some of the users are outside the Wi-Fi network, so they can utilize the Wi-Fi. And some of the users which are present just interference of the both or more than one Wi-Fi, those users may experience lesser data rate from the Wi-Fi, then they can utilize the Wi-Fi also. And similarly, when the user moves out from the Wi-Fi coverage to the out of that coverage, then they can switch from the Wi-Fi to the Wi-Fi by utilizing handover technique. Here, definitely handover overhead will be there. Still, with the handover overhead, also we are getting the better performance of the hybrid Wi-Fi network as compared to the standalone Wi-Fi network or Wi-Fi network. We can see that whatever Li-Fi devices we have developed in-house, I have already shown in the previous slide. This is the panel of LEDs, which is acting as transmitter, and this is the access point, which is having the live photodiode for the uplink communication, and it has the FPGA board, which board has the signal processing kit as well as modulation, demodulation, A to D converter. Everything is inside, and this is the just indicator which will show that light is on, and means light is blinking, means communication is going on. This is the dongle which is connected to the user device. Here, this is the photodiode which will receive the visible light, and this is the IR LED which will just send back the data to this photodiode in the uplink communication. So in this way, we can do the means like bidirectional communication between the transmitter and receiver. I'll show some demonstration also. So we can see that like this is one of the scenario we built. Here we have three users. This is one of the user which is hybrid user, which can connect to the Wi-Fi. Whenever it moves out from the Wi-Fi zone, it will switch from the Wi-Fi to Wi-Fi access point. And here two users are there. Always they are connected to the Wi-Fi. So this user is moving. Like this is a mobile user. Whenever this user moves from this zone to this black spot, definitely it switches from this Wi-Fi to Wi-Fi. Whenever it reaches at this spot, then it switches from this Wi-Fi to Wi-Fi. Similarly, we have covered whole the room, and we have analyzed the performance of this hybrid network. We have built this kind of scenarios and compared with the standalone Wi-Fi network, and we observed that like standalone Wi-Fi network average throughput is performing lesser than our hybrid network. Whenever we our mobile user is there switching from the Wi-Fi to Wi-Fi, definitely the contribution of the Wi-Fi is providing the or improving the rate of the user. So two user case and three users case we have also observed. Similarly, packet loss also we observed, like in case of a standalone network, we are getting higher packet loss as compared to Wi-Fi, because here we can see that if number of Wi-Fi users are increasing, definitely we may also face the congestion issue, and we can also uh, lose some of the packets. But in case of Wi-Fi communication, that is uplink and downlink, they are using different channels, so there is the less chance of um, losing the packets. So in this way, packet loss performance also we find that hybrid network performs better than that. So this is one of the demonstration of that network, whatever I have shown in the previous slides. This is available in this YouTube channel. Also, we can see different scenario. We have also tested the same thing. We can see here at the server, we are running this video. At the client, we are getting back this video, and we can see that here the video transmission bandwidth, and this is the ping packets also running. Similarly, whenever we are switching also, you can see that whenever the lumens value it falls down, it switches from the Wi-Fi to Wi-Fi. Still, video streaming used to go on. This detailed demonstration is available in the YouTube channel. You can observe that. Going ahead, if we are utilizing Wi-Fi network, but still the user demand is so high. A hybrid Wi-Fi network is not able to provide. Then what is the other alternative? That is nothing but link aggregation. Like you can see that same network I have considered for Wi-Fi network and one Wi-Fi network, and some of the Wi-Fi users are there. They are already using Wi-Fi, and some of the Wi-Fi users are there. They are utilizing the Wi-Fi. Some cases like this user 2 and user 7, they are having the connections from the Li-Fi or Wi-Fi because they are in the zone of the coverage zone of the Li-Fi and Wi-Fi. If they demand for the like AR VR application, very high demand applications, then we can utilize Li-Fi plus Wi-Fi for those users, so which will be able to provide the higher data rate based upon the user demand. These are the link aggregation. So the important thing is that first of all we have to identify that which user actually require the link aggregation and the location of the user. If the user location is not in the area of coverage where the Li-Fi and Wi-Fi accessibility is possible, then this is the difficulty. So therefore, we have to think about that installation of the Li-Fi access point and Wi-Fi access point. Accordingly, we have to design the AP plane and the user plane. So that is again designing challenge. So this is one of the important application of the link aggregation in hybrid Wi-Fi Wi-Fi network. Further, in this hybrid Wi-Fi Wi-Fi network, important thing is that like we have to see that how this means link aggregation whenever we are doing, how to do this resource allocation. This is one of the biggest challenge. Here we can see that these are the constraints whenever we are trying to improvise the throughput or maximize the throughput in the link aggregation network, hybrid network. Users demand, users location, and whatever the backhaul. If the backhaul is not available, we cannot provide also the higher data rate based upon the demand of the user. Therefore, these are the constraints whenever we are going to do the resource allocation for the user from the EP. And these are the challenges. We also get the challenge of rate allocation. How much rate should be allocated to which user? We need to see that fair is it fair allocation or not. That means some of the users should not get the very less data rate, and some of the users should not get very high data rate. Therefore, we need to look into those challenge also. And important thing is that already I have mentioned we need to identify which user actually require the link aggregation. Based upon these constraints and challenges, we need to do the resource allocations. And we have also done this resource allocation problem also. We have solved it. Finally, we have achieved that we have proposed this platter technique, which is providing the better data rate in three users fairness constraint we have considered. That is light fairness, and this is moderate, and this is the tight fairness. All the cases it is approaching to the upper bound, and this is the lower bound. So in this case, it is providing the better performance as compared to means other techniques. And we also guarantee here that we are uh, able to provide this 50% of the data rate. This is the guarantee, this claim we have done in this research paper. So for more detail, you can go through this paper so you can get more information about this resource allocation problem. So let's see that whatever the disadvantage of the Wi-Fi, I have talked a few slides before. We have the Wi-Fi, which has the disadvantage that we have to share the CSI feedback with the Wi-Fi access point, which is means like one of the means important limitation in case of beam formation or in the spatial multiplexing.